Hi everyone, this is Dr. Vlsi from EC Department, SNS College of Technology. Here we are going to see the topic Comparative Study of Logic Families in Vlsi. So this is the outline of this video. And whatever the digital circuit, we can, while designing in VLSI, we can use different logic circuits like static CMOS, dynamic CMOS, domino CMOS, etc. So with each logic families have one specialization like better power consumption, better speed, or better area, or better noise immunity. So that is the key outline of this video. So we are going to see the different logics and how it is better than other logics. We are starting with static CMOS logic. So here is the general structure is given. From this general structure, we can see that in the pull-up network, every transistor will be of PMOS transistor, and the pull-down network is consisting of the NMOS transistor. So when the logic is 0, the PMOS will conduct and NMOS will off. So likewise, when logic is equal to 1, input is given as 1, the NMOS conducts and PMOS will become off. So based on this formula, the functioning will happens for whatever may be the circuit. So the advantage of this static CMOS is no static power. So no static power other than the gate leakage or multi-threshold leakage or some other leakages. So other than this, there is no static power or switching power, anything. So here we are having high noise margin, because of it is reliable. So well suited for large scale designs. So while coming to the pseudo NMOS logic, so instead of pull-up network, we will be connecting only one PMOS transistor where its input is connected to the ground. So its working is when NMOS network pulls down for logic 0. When logic is 0, NMOS will become switch off, and when NMOS is off, then PMOS starts to conduct when logic is equal to 0. So that is the case here. So here the advantage is reduction in number of transistors. So this is the time for activity. And coming to the dynamic CMOS logic, so while comparing to the static CMOS, here number of transistors are reduced with the given general structure. So here only pull down network is considered, and instead of pull up network, we will be having the one PMOS transistor and one NMOS transistor connected with the input path in clock signal. So the clock signal is considered with two phases, pre-charge and evaluate. When clock equal to 0, it is called as a pre-charge mode. When clock equal to 1, it is called as a evaluate mode. So based on the clock signal input, so the way output may vary. For example, when pre-charge mode, the output always, that is PMOS will conduct, so output always equal to VDD. But when clock equal to 1, NMOS will on and PMOS will switch off. So based on the pull down network, the output may discharge or output will be available in the output path. So that is the case here in the dynamic logic. So it is especially used for high speed applications. And then coming to the domino logic, so it improves over dynamic CMOS. So while going for dynamic CMOS, when connected in cascaded mode, it is very providing faulty outputs, which is overcome here with the help of the domino logic. So where the output is connected along with the static CMOS inverter. So this is much needed when comparing to the dynamic logic. So its advantage is nothing but eliminate cascading problems, maintains non-inverting property, and faster than static CMOS. So it is especially used in arithmetic circuits in CPU, signal processing unit, etc. So and then coming to the transmission gate logic. So here in transmission gate, we will be using two types of transistor. One is NMOS and another is PMOS, which is connected with control signals C and C's complement. So NMOS passes strong 0 and weak 1, and PMOS passes strong 1 and weak 0. So based on the given input, So mostly strong 0 means it will pass through the NMOS, and when it is strong 1 means it will pass through the PMOS based on the control signal. So this is the case here. So by using transmission gate logic also we can design any VLSI circuit. So it is especially used in multiplexer application or XOR gates or bus switching, etc. So here is the detailed comparative analysis about the previously seen different logics. Here static, CMOS, pseudo, dynamic, domino and transmission gate. So here we can clearly see that which logic circuit is better in which features. For example, domino and dynamic are better in speed, very high speed, and transmission gates are especially used in multiplexer, and pseudo is used in decoders, static CMOS is used in processors. So as a conclusion, we can conclude that no logic family is best for all classes. So based on the application, whether speed is needed or less power consumption is needed or better area is needed, based on the application we need to choose the better logic circuit. So that is the conclusion here. So this is the real world takeaway also. So modern VLSI system do not rely on just one logic family. Mixed use is common. So for higher or complex circuits, we will be using static CMOS, domino and transmission gate for several applications. Here is the assessment session. Which logic style uses a single always on PMOS as a pull-up network, pseudo NMOS logic, and dynamic CMOS logic works on 2 clock phases that are pre-charge and evaluate. Which of the following is the major advantage of domino logic over dynamic logic? So ability of cascade multiple stages is the advantage of domino logic. And the transmission gates are especially used for which application? That is for multiplexer and XOR gate application. Okay, thank you for joining in this video. We have seen about different logic families that we are using in the VLSI circuit design. We can join in the next video. Thank you all.